Good afternoon, everyone. Thanks very much, Katerina, for the introduction of the introducer. I'm very pleased and it's an honor to introduce Professor Francis McGlone. He's the head of the Somatosensory and Affective Neuroscience Group at the John Moores University of Liverpool. And I think we should be all aware that we're very lucky to have him here today because he's absolutely obsessed about CT afferent system, and I think he's going to try to answer the most important question, which is, what is this system for? Thank you very much.
Well, I will also offer my thanks to Katerina for putting the muscle behind all this and making it happen. Is that okay? Can you hear me okay? Yep. No.
Just speak up. No, you don't have to.
I won't hold it. Katerina dug this out from somewhere, and I thought we'd start with where we've come from and some of the more lunatic interpretations of social touch that the founder of behaviorist school of psychology came up with these rather interesting advice to young parents in terms of their child. Really just to remind us, I think, of where this system is really making its impact and is beginning to make a bigger and bigger impact as more and more people become aware that we are wired to respond to particularly the kinds of touch that Johan and Håkan were describing. So this is from one of Charles Spence's billions of papers where they published an overarching view on the disciplines that are relevant to touch. The one that, as a neuroscientist, I will be focusing on during this talk is neuroscience. And I'm getting more and more interested in the role of these C-tactile afferents in early stages of development, in utero and in the first weeks and months of a baby's life. And I'll try and put some muscle onto that. What I'm going to do, this is really, I guess we have all, in respect to Johan and Håkan, this is going to be a smorgasbord. What I'm trying to do during this talk is just to put bits of a jigsaw puzzle down on the table. They don't all join up, but what we're hoping in the ensuing years, and it may be decades, that as more and more pieces are put into this jigsaw puzzle, we will get a clearer and clearer understanding of just what the hell these nerve fibers are actually doing. The model at the moment, as you've seen, is the affective touch hypothesis. Peppered through this talk will be certainly the reason I'm here, and I think probably most people are here, is the work that Johan described that Orca Valbo significantly contributed to by dedicating a large part of his life to basically characterizing what this population of C-tactile afferents are actually doing at the first order neuron level. I held a meeting in Manchester, I think it was about 15 years ago. It was called Touch, Temperature, Pain and Pleasure. But it was a meeting where we were bringing together people that had an interest in various cutaneous modalities. So although we're focusing on CTs, there's a whole range of other afferent nerve fibers feeding information into the central nervous system. And Orca gave a talk, and I've taken some of the snippets because it's salutary to listen to Orca's opinions 15 years ago.
Some experience that the skin contact with another individual may have an emotional impact that is dependent on your emotional state in the first place. And when you are emotionally out of balance, you are threatened, you are depressed, then skin-to-skin contact may have a strong impact and relieve anxiety, whereas when you are in a different emotional state, the effect is not that strong. But I wonder to what extent you think it would be possible to explore scientifically the significance of the subject's pre-emotional state with regard to the responses to skin-to-skin contacts. Would it be possible to define and assess whether the psychophysical response or the bone response in MRI studies is dependent upon the emotional state of the subject in the first place? I think these issues are of interest not only from basic physiological point of view, but also in relation to clinical medicine. And I wonder whether you think it would be possible and whether it would be ethically acceptable to go into clinical states, say, for patients with depression or patients who have got grim information about their own health state, and explore to what extent their response to pleasant skin touch is dependent on the profound emotional states.
Just have one more.
We concluded in our first paper from 1993 that the essential role of the CT afferents and their central effects are in the limbic area rather than the cognitive, discriminative and motor control functions. And our next question was then, what would be the biologically most significant stimulus that within the limbic sphere that would excite these low threshold mechanoreceptors?
So you can see there 15 years ago, 16 years ago, there's some real insight into Orca's interpretation even then of the potential role that these C-tactile afferents are having. It layers way beyond this first order neuron, right the way out to these more cognitive factors that they may have a particular function in manipulating or modifying. Just to sort of, I mean, as a started life as a neurobiologist, I always like to join things up wherever I can across animal kingdoms. And this sort of struck me as a, you know, we know this is the animal that we know most about. It's got 950 neurons, 5,000 connections. They've mapped C. elegans in terms of the connectome beyond, I think, the level that we know in virtually any other species. But guess what? This thing's got two massive neurons that respond specifically to gentle touch. And here in this simple experiment, you can see a worm here that's grown in a colony. So it's touching its affiliate worms and it's growing healthily. And up to its full length, it's only a few millimeters. This is a millimeter, this bar. It's only about 4 millimeters long. Here's one poor little chap that didn't grow up with any brothers and sisters, and he's hardly grown at all. Now this is just, you know, I'm inferring here, but this is evidence, well not evidence, but it's leading us to a possible evolutionary significance of this modality in any species, knowing there's an out there and an in here. It has to be mediated by a population of nerve fibers that have that coding property. I'm just going to go back a bit to the sort of late 1990s. I think Greg and I were probably the first people to ask this question: can you actually measure affective touch? Is it something that can be psychophysically quantified in a laboratory environment where we can get some hard data? Now, Greg at that time was interested in motion coding and how tactile motion is encoded in the same way others have been interested in visual motion. So he developed this stimulator, which was a rotary motor here. Can't really see it too well, but there's a soft brush here, which is moving up and down the face through this aperture. And the simple question that was asked is, how pleasant is that stimulus when it's moving up and down? And we moved it up and down at these 3 different velocities based on the data that was coming from Orca and Johan. And guess what we found? Here's our three velocities, 0.55 and 50 centimetres per second. Just look at the velvet stimulus here, although these tuning characteristics are there for all of these surfaces. This is a log scale, this is the rating of pleasantness. One thing pops out immediately, and I'll come to that later in the talk, and that's this amazing inverted U. So this sort of semi-quadratic function is characteristic of these C-tactile afferent responses, again, as Johan and Håkan has talked about. Another interesting aspect is here is that not only is 5 centimetres per second for the same physics is rated as most pleasant, we get this heterogeneity now in terms of the body parts that are being stroked. Now, of course, we could infer from this that these different subjective responses may well reflect differences in innervation density to these different body sites. As far as we know, the body is not homogeneous in terms of its response to affective touch, and I'll come to that a little bit later. We then went on and spent a good few years building this robotic tactile stimulator. There's $10,000 worth of false transducer in this hub. There's a very sophisticated program running it. If you're going to deal with a touch system, it actually takes a phenomenal amount of engineering to be able to deliver a tactile stimulus which is not contaminated by vibration, by other mechanical stimuli that you don't want to measure. And this was the beginning, really, of looking at the heterogeneity in ratings of affective touch. So if the body was homogeneous for its response to affective touch, and that the innervation was the same everywhere, all of these bars would be exactly the same height. They're not. If we did this at 20 centimetres per second, which we did, all of these are lower. So the velocity tuning comes out. We also looked at force, and force sensitivity is also key in terms of affective responses. And here you can see the different stimuli that we were using, and again a heterogeneity in terms of the quality of their input signal to the mechanoreceptors. Steve Guest spent a good few years developing a touch questionnaire, and coming from a pain background, we had no way of asking people in a quantitative way what this touch felt like. We are crap at subjectively interpreting some sort of emotional thing. You know, people will throw words out. The McGlone Pain Questionnaire, of course, is a way of quantifying the subjective experience of people's pain. And the important thing about the McGlone Pain Questionnaire is that it uses language which gets at the discriminative components of pain, i.e. stabbing, sharp, etc., burning, but also a list of words that get at the emotional or affective side of pain. And that's exactly what Steve did in the development of this questionnaire. This was ball aching, a good few years of work, actually. This started with a colleague of mine, Ron Murillo, who went through the Oxford English Dictionary, getting every word he could find that was associated with touch. Anyway, what this does, you can look at the publication, is that we're using a different language when you're extracting the emotional properties of a tactile stimulus rather than its discriminative. Just to sort of put another sort of level to this, what this graphic shows is glabrous skin, hairy skin. These are these A betas that Johan described firing immediately. This is most people's experience of touch, but you can see that other C system is wafting in afterwards, coming in a delay, mixing in with that experience of touch, but had an affect or emotional level. I won't run all this the way through, but we know a fair amount about the first order neuron. We know very little about the transduction process, and hopefully Emmanuel will enlighten us more to that. We don't know too much about what happens when these C-tactile afferents, and I'm talking about humans now, as well as the rodent work, come into the dorsal horn. David Andrew has shown that they're projecting to inner lamina 2. The output layer of dorsal horn is lamina 1. We don't know yet exactly the spinal pathway, the spinothalamic pathway of CTs. I'll stop that. But we're looking, with a colleague of mine, Andrew Marshall, we'll be running some studies soon with anterolateral cordotomy patients who basically have their anterolateral tract cut. So the C fibers to the contralateral side of the body are basically burnt. not only do these patients are pain-free on the contralateral side, of course, they should be responding differently to affective touch. If that's the case, then we may have some more information about where the second-order neurone is.
Cerebral systems, in addition to the tactile C system, may be of significance. There may be the myelinated system, and there may be more deeply located systems that respond not only to light touch, but to more strong but innocuous deformation of the body parts.
The ORCA here is basically pulling back out from just the CTs and recognizing that, of course, when you touch someone, a lot of other things are going on in terms of touch. I'm adding here a couple of things to Johan and Håkan's list of the physiological properties. And this is his evidence for distal to proximal innervation. We'll talk about that later in the post on this, what we're calling a hedonic homunculus. Is it the animal where it shows that there aren't many CTs in the distal parts of the limb? They seem to be more densely, or they're not seem to be, they're more densely represented around the trunk. We've got data now that shows in humans that there may be a hedonic homunculus. And again, these are not serving any purpose that could possibly be discriminative. Now, I found a button I shouldn't press as well. So affiliative touch, this is the area that this society is sort of basing itself on. We can see examples of this in terms of grooming, nurture, etc. And many researchers previously have begun to understand or to research into this property of behaviour in animals, primates, humans, etc., in terms of the role of touch in various behaviours. And again, an area that I'm getting particularly interested in is these early interactions between the mother and the infant. And this last statement, appetitive approach process bring an individual into contact with unconditioned incentive stimuli. Consummatory processes bring behaviour to a gratifying conclusion. These are important aspects that we need to understand about what this CT system is doing. I'm throwing some sort of just observations out here, really, just to sort of whet your appetites. This is data. None of this data was actually predicated on the fact that there's a C-tactile system. It's basically looking at behaviour and interpreting the reasons for that is something to do with touch. This one particularly amuses me for some perverse reason, where Tiffany Field, who's done a phenomenal amount of work looking at this nurturing touch systems, looking at different cultures now. And I think there is, we need to bring some social scientists in on this meeting more as well, looking at the social consequences of societies that are more comfortable with interactive touch and those that aren't. So, Harlow's study we don't need to really dwell on, but going back 1922, one of the earliest studies on the benefits of touch from Hammett, and that the references down here reported that rats that were infrequently handled were more timid, apprehensive and highly strung. This really is being picked up now in a phenomenal way by Michael Meany's group, looking at the epigenetic consequences of early life experiences and showing robust changes in the infant that is touched or not touched, or in the rat's case, licked and groomed or not licked and groomed. Again, Harlow knew nothing about C-tactile afferents, but made this observation that these infant monkeys would far sooner cling to a cloth surrogate than a wire surrogate that had the reward of food associated with it. We can't say this is CTs, but this is another piece of the jigsaw puzzle in a sense, where this is affective touch. That study, of course, opened the door to research concerning the necessity for touch in development. And we get this list of observations coming out from various studies. Again, none of them predicated on a recognition that there's a neurobiological basis for these observations, but nonetheless, they're secure observations in terms of, and of course, what we're suggesting is that these observations are explicable now by the C-tactile system. So, touch matters. Across the lifespan, social touch interactions have been shown to benefit an individual's physical health. Although I'm sort of leaning towards a sort of early nurture, I think there are significant contributions to this kind of affective touch at the later end of life, and particularly in conditions of dementia and Alzheimer's. Is this system still open? Is the first system to come online in the developing infant at about 10 to 15 weeks? The fetus will respond to a mechanical stimulus. Is it the last one to go offline? And I'll show you some tantalizing data from a colleague of mine in Russia in a moment. This is picking up on this work again that's coming from Meany's group, Rankin and others. Again, not predicated on an understanding, as far as I understand, or a recognition that there's a neurobiological basis that's encoding this licking grooming, but this licking grooming is touch. It's touch at the frequency that we know is activating preferentially C-tactile afferent. So the behavior we observe in these animals maps on to the nerve fiber characteristics that Johan described in his talk. And there are phenomenal differences in the adult behavior of a rat pup from a low licking grooming mother or a high licking grooming mother. And again, the caveat, extrapolating this to humans, we need to be careful, but I think there's evidence growing that these do translate in a definite way. So these are having direct physiological effects on the hypothalamic pituitary axis, which manifest themselves in the adult mouse in terms of their response to stress and their reaction to it. A rat pup from a low licking grooming mother does not cope with stress at all well. Their HPA axis is on red alert in comparison to those that come from a high licking grooming mother. And there are also changes in the brain that I will show you some human data on to corroborate as well, again, that will hopefully build this story in terms of just what these CTs are up to. So, maternal touch in the animal work, a powerful suppressor of HPA activity. Just one thing on the epigenetics, by the way, is that certainly in the rodent work, a rat pup from a low licking grooming mother, if it's female, when it itself becomes a mother, will be a low licking grooming mother. That's what epigenetics is all about. Epigenetics is moving down through generations. Again, we're humans. The phenomenal plasticity that I think is evident in the human brain, these things aren't set. You can't translate that out to neglect of a baby in a human. So increase hormones. This is all evidence that is building further recognition of this early experience of touch. And again, these are these comments I've just mentioned between the high licking and low licking grooming mothers. This is incredibly difficult, painstaking work to get this data, but it's robust. Looking at human, gentle touch reduces pain responses and reactivity to stress. I probably won't talk about that today, but we're getting some really exciting data only yesterday from a group in Oxford that are recording EEG in infants that we're using this stroking intervention to a pinprick, really based on the work that Håkan has been doing. I'll mention this increased vagal activity in a moment, and we've also seen these physiological effects in increased growth and the immune system. These are all very, very important fundamental influences that just this little stroking behaviour appears to be impacting on the development of these infants. I'm going to whiz through these because you're best to sort of look at the paper. This was Jennifer Glaze's group. Here you're looking at gene expression. And they're getting more and more obsessed with these critical periods, these sensitive periods during which early prenatal and postnatal development significantly affects what's happening next in the way the brain is wiring up. And how I sort of have this, I'm always a building, I have this image of the Taj Mahal, is that you're laying down the foundation of this amazing building. What's in that foundation is absolutely critical to what you're putting on top of it. And you can't start putting the, it's a bit silly, you can't put the first floor, you can't put the second floor in before the first floor. Everything is dependent upon what's gone before. And the way that this phenomenal complexity of the human brain is making these internal circuits and networks is built on what's happened before. And these critical periods, certainly in animals, are irrecoverable if something doesn't happen at the time when it should. This particular study is looking at BDNF, a key mediator of activity-dependent processes that have a profound influence on development and plasticity. Cutting here, brief and repeated experiences with a nurturing foster dam have been shown to have a long-term effect on the methylation, even though this manipulation did not produce any obvious behaviour. I kind of like seeing things sometimes that there isn't always a behavioural correlate, but you can get a measure that that effect there's an effect in the brain that is not necessarily always visible through behaviour. Behaviour may be a bit of a blunt instrument sometimes in order to do these measurements. So these studies provide support of DNA methylation modifications as biological consequences. These modifications, these changes, are at a circuit level changing what's being developed. This is a particularly nice one that basically we've got the same kind of manipulation here. Here we're looking in the prefrontal cortex. Obviously this is an area of the brain that controls a lot of complex behaviours. And what we're looking at here is myelinization, i.e. the ability of this system to not only wire up properly, but it also function properly in terms of the degree of myelinization. If the myelinization doesn't happen, that nerve won't conduct any information, and basically you'll have a dead zone. Again, what's happened here is that this, in the control group, you can see PFC, normal myelinization. Look what social isolation is doing. In the prefrontal cortex, there is a significantly reduced myelinization of axons in the white matter. This is not found in nucleus accumbens or cerebellum. So this isn't a general effect across the whole of the brain. It's specific to parts of the brain that we would suggest have a very clear social function. These are a bit too crowded, these slides, for you to take in, but I want you to just get the essence of what I'm kind of building a case here for. This is looking at the methylation of genes in the medial prefrontal cortex. And again, what we see is that that interaction, mediated by early nurturing experience, is giving clear indications of differences in the way these brain structures are developing normally or atypically. And again, the manipulation is nurturing care. And this is going on in the first days and weeks of these animals' lives, and the consequences are robust. Here's another example from Alvera's group. Neonatal handling reduces stress-induced enhancement of chronic mechanical hyperalgesia. And again, this may link to some extent to what Håkan was telling us about. Neonatal handling of rat pups induces resilience to the negative impact of stress and pain. So these early nurturing experiences, this early handling, is, if we go back to its effect on the HPA axis, is building in resilience to later life experiences. And again, the animal work is building some quite tantalizing models that enable us to quantify the effect of that early tactile behavior. So neonatal handling induces a smaller corticosteroid response in adults exposed to a stressor, as well as changes in CNS neurotransmitter systems. These are big effects, yeah? These are major alterations in the phenotype of the adult. This is another one that I'm particularly fond about. This wasn't really based on an understanding, it wasn't based on an understanding of the fact that there were C-tactile afferents. In this study, done by Leonard et al., I think they're in MIT, this study tested the effect of touch on children's compliance behaviour in a modified delayed gratification task. Because those of you with kids know that you stick a kid down in front of a reward and it will just want it. Yeah, this immediate gratification is a natural sort of response. So this is quite a significant test of a kid's ability to basically withhold that reward. The only manipulation here is that one group of kids weren't touched, the other group were just basically gently touched on the shoulder. And what we find is those groups that were gently touched on the shoulder were delayed their gratification. Again, another little piece of the jigsaw puzzle, and also more evidence, I think, from some of the work that we've been doing that's sort of demonstrating this hedonic homunculus. This is going back again to, well, up the ladder really to social grooming in primates. This is a classic study now that we've seen many, many times. Is it, what Cavern did is look at grooming behaviour in talipin monkeys. One group were given naltrexone, which basically blocked the endogenous opiate system. The other group were given non-sedative doses of opiates. They weren't out of their heads. These were non-sedative doses. Grooming bouts were looked at again under the influence of low opiate and naltrexone. The group that increased their grooming most significantly were those that had the opiate blocker blocked. Again, inferential, but we here unmask the fact that this social grooming is engaging the endogenous opiate system, and it's pleasant. And anything that's pleasant is going to be done again. So these are evolutionary principles of reward that promote a behaviour that has some benefit. And like the pain system, obviously promotes behaviour that is going to keep you alive, which is why we need C nociceptors. We need C tactile afferents as much as we need C nociceptors. So that basically summarises the Cavern study. Here's another piece of our jigsaw puzzle. This is a poster I came across at Society for Neuroscience. This is the expression of C low-threshold mechanoreceptors in dorsal root ganglia during postnatal development. So the bottom line of this study is that what they did here was rip all the dorsal root ganglia out in pups a day or 2 days old, P1, P2, right the way through to adolescence at P60. Look in those DRGs for exactly the kind of markers that Johan and Håkan were talking about, this tyrosine hydroxylase marker, a marker that shows that these CLTMs are there. This is quite beautiful in that this is going up the spinal cord, and this again shows that there is reduced staining in the limbs and more staining on the trunk. So this is our sort of hedonic homunculus, if you like, mapped here, where the more staining DRGs are those that are feeding the trunk. And again, that came out from the Liu paper, the genetic visualization paper. The bottom line on this, and what's fascinated me about this paper, is that the expression of DRG emerges in the second postnatal month P60, rather than in the early stages of this mouse development. But this kind of throws the cat amongst the pigeons in a sense, in that we've been building our story on the fact that these CLTMs are having their most profound influence in the early days, early stages of postnatal development, all the licking, grooming stuff, pups 1 or 2 days old. This is where this system is having its optimal effect. There may be reasons why they did not get this staining at the young age. What I'm suggesting here is there may well be more than one population that express themselves in different behavioural periods. So during that first early days of the mouse's life, where this affiliative nurturing touch is absolutely critical, there's a system which is basically promoting, responding to the licking, grooming, and plugging into all these systems we've seen. But there's another stage in the animal's life where it becomes socially active now, away from the mother, but with its siblings in a social environment. This is all the rough and tumble stuff. This is play. So do we have another system here that is basically coming online, promoting the rewarding aspect of that social play behaviour prior to that animal becoming a full-blown adult? This is, say, a smorgasbord that you're being delivered here. I don't want to exhaust you too much. But what we're hoping to do is just sort of build an evidence base for just what these CTs are up to. This is a study that Håkan helped set up with this massive fin brain project. And here they're using FNIRS to record activity from areas on the contralateral brain of these infants in response to gentle touch. And what we're seeing here is that this system of response to slow brushing is optimal in terms of blood flow responses, leading Hokan and the group, and this is early data, there's far more evidence required to corroborate this, but the conclusion of this is already at a very early stage of development, the human brain has different ways of processing this discriminative fast touch and slow touch. So this is early information in human babies that, yep, they are wired and responding to gentle affiliative touch. I've got some fabulous data, in fact, to corroborate that. This is a study that Lena Loken did, infant sensitivity to pleasant touch. Lena basically, with Fairhurst, is now stroking at our CT preferred and non-preferred velocities, so we can go medium, slow and fast. And this graph shows that an individual infant's heart rate during the 10 second before and the 10 second during stimulation as a function of stroking velocity. And we get a clear impact of slow stroking in terms of the response to the heart rate measures, arousal being measured by a pulse oximeter here. So again, another measure of the impact of CT preferred stroking touch, this time on infants. Now this is, I suppose, what we're hoping will happen with this meeting. I just back from a meeting in Eindhoven last weekend. It was the World Association for Infant Mental Health. They weren't aware of this system either, actually, but one of Martine van der Pil, who actually invited me, had read about this work on CTs. She was doing some work looking at this respiratory sinus arrhythmia, basically a measure of vagal tone. The RSA variation is a variation in heart rate that occurs during a breathing cycle. Here she's looking at infants 1, 2, 4, 8 and 12 weeks. She's basically dumping the infant on, not dumping, placing the infant on the mother's chest, skin-to-skin contact. The mother is being trained to breathe at certain rates. And guess what happens? The respiratory sinus arrhythmia locks synchronously between the mother and the infant. They're in vagal tone and in vagal tune. What really blew Martina away, because she thought she'd have a look at this touch stuff, is that there was a large decrease in heart rate when the mother was caressing this infant, more so than just the skin-to-skin contact. The other interesting thing about this, which is, I suppose, feeding to my obsession with the very early stages and how critical touch is that this RSA is no longer present after 12 weeks. So after 3 months, you won't get this locking synchrony. Is it possible that the changes in C-tactile function are also time-dependent in a critical period? Now, where I think this is relevant is a collaboration that we are building with Professor Mary Renfrew at Dundee, who is leading a very large group on breastfeeding and behaviour, and she does not think that nutrition is the one and only aspect of breastfeeding. But look at the data. On basically what I've just said about that early contact, skin contact, and all the other influences of early skin contact, these are the data across the United Kingdom in incidence of breastfeeding up until 6 months. At least a lot of it's going on in these first 3 months, but it tails off. This was taken to look at improving neonatal care in large unit study now, where this kangaroo care, again, not predicated on the fact there was C-tactile afferents, but observations that physical skin-to-skin contact between a mother and an infant appeared to be good for the development of that infant. And what happened is that this kangaroo care has had these enormous, significant impact on the way that the mothers are and the babies are surviving or in these particular institutions. And this is just some anecdotal reporting from mothers and fathers that have experienced this skin-to-skin contact. There's something, I was going, we can't argue with 3 million years of evolution. This is natural behaviour which is predicated on a natural desire to basically keep this skin-to-skin contact fundamental in the early stages. Another one, mother's touch from prenatal stress. Stress in pregnancy can have an effect on an infant in later life by reducing the activity of genes that play a role in stress response. We've seen this in the rat work. We're now seeing this in humans. This is a fabulous paper from the Liverpool group, Helen Sharp et al. The impact of prenatal stress on an infant's development can be either positive or negative, depending on the type of environment that that child encounters. Some children may experience these effects through being more prone. And again, we get this genetic predisposition coming in here. What this study found by looking at every single measure they could make, the only one that popped out was that mothers who stroked their baby's body in the first few weeks after birth may change the effect that stress during pregnancy can have on early life development. So hopefully, so this is, when I've locked in with a colleague, an EEG chap in one of the Moscow State Universities. I gave a talk out there a few months ago. They sort of bought into this idea of C-tactile, the effects of C-tactile stimulation. This is a work that they've done on coma patients. And the subjects were passively touched by a soft, rough or sharp object at their left wrist. Stimuli were presented with the velocity tuned to the CTs. And what do they find? A predominant delta and theta power decrease compared to background level for these coma patients. This information is getting in and manifesting itself in these EEG signals in patients that are in a coma. And the last few slides are really extrapolating something that has sort of dawned on me many years ago, that if this system failed, what would the phenotype look like? And together with Carissa, I think we did some of the earliest studies looking at whether the touch system was in any way implicated in autism. And our view is that if this system failed, we may expect that phenotype to be looking like some aspects of autism. And there's evidence now with Kevin Pelfrey's group that that's what's being corroborated. We know that these autistic responses, we get this measure of affective touch, the inverted U, is basically showing us that the normal characteristics we get in the sort of neurotypicals is not present in those on the autism spectrum. And just a few more. These are just all the inverted U from our own laboratory. And in fact, these are mostly appearing in posters. But this hedonic homunculus basically is describing the fact that when people see touch on the back, they rate it as far more pleasant than seeing touch on the forearm. This is, again, looking at normal people, but scaled against the AQ, the autism quotient, we get exactly the same inverted U. The higher on the AQ, the sharper the inverted U. This one is a part of a poster that Paula Trottle will show, so I won't dwell on that. So what do CTs do? The affective touch hypothesis, really I think brought on primarily by India, brought this stuff together in terms of